Hello friends, welcome back to Light Tutorials. Today we learn the MATLAB code for sampling rate conversion. Okay, right. So sampling rate conversion is a process where we either upsample the existing sequence or we downsample the existing sequence based upon the requirement. Okay, few applications they need they need upsampling. That means we increase the sampling rate of the existing signal. Okay, so as to get the correct information from the transmitter end. Or else, suppose if we consider an image, if you want to scale an image, then you need to upsample the number of sequence or upsample the given image. Okay, so in few applications we upsample it and few applications we downsample it. Okay, today I'll show you both of these upsampling and downsampling with a MATLAB code by considering a sinusoidal signal. Okay, so here the important factors for this writing this code are, or else the important components of writing this code are: first is frequencies. What are the two frequencies you want to upsample and downsample? Other is factors of these frequencies, sampling factors. Okay, upsampling factor and downsampling factor. Okay, now I'll show you the code. So here is the code. So first thing, input the length of the sequence n equal to. You're asking the length of the sequence. Okay, you can give it any number. Mostly this type of sampling conversions they are for the sequence of the samples greater than 30. Okay, you can go with the number greater than 30 because less than 30 it is not required for sampling rate conversion. Okay, not so useful. The for the sequence greater than 30 we need this. Right, next f1. In f1 I store the input. What? Enter the first frequency component of the signal. What is the first frequency component of a expected signal? And the second frequency component. Okay, then x equal to sine. I have added two sinusoidal signals here with the different frequencies. After that, L equal to input that upsampling factor. Now X is a discrete signal. Okay, in this signal you have some samples already. That is a basic signal you have. Now what I need is I need to upsample it. Upsample means padding zeros to existing signals. How many zeros? L minus 1 zeros. Okay, so x1 equal to zeros of 1 comma L into n. Okay, L into n, you are padding zeros to the existing sequence. Okay, now here n1 is from 1 to L into n. What is L into n here? Capital N is what? Your input sequence. The number, whatever number you give. What is L here? Your factor. That many zeros from 1 to that many number. That number n1 is changing. Okay. It is a vector, or else you can say it is a timing interval. It is an interval from 1 to that many samples, and A is changing with the size of L. Okay. For every 4 samples, you have one upsampling. X1 of A is X. X1 of A. That means this vector is assigned to X now. The signal M equal to input the downsampling rate M equal to. Okay, now you give the downsampling rate. Again, you consider the X and you consider this downsampling. Here I am changing with respect to downsamplings. Your downsampling means removing the existing sampling rate, sampling free samples from the signal. Okay, that means you will decrease the memory whenever you're not required. So I'm using stem here. I already told you why we are using stem. It is for, as it's a discrete signal, we need to use stem here. I'm plotting all these sequences. Okay, now I'll run it. Now it is asking enter the length of the sequence. Let us enter the length of the sequence is 130. Okay, first input frequency I'll take 2 kilohertz. Second, I'll take it as, let us see, 1000 kilohertz. I mean 1000 hertz. Upsampling factor 3, downsampling factor 2. Okay, see, here is the thing. This is the input sequence. Two sinusoidal signals we added. Okay, the discrete frequency with the discrete frequency and amplitude. Now it is upsampled. Now you see here there are so many samples from here to here. What is upsampling? I told you upsampling is adding the number of padding with number of zeros. This is the zero amplitude. Wherein here we added so many zeros. If you see, they are overlapped with each other. But it is a downsampling. We have removed so many samples here. Okay, unwanted samples, or you can say the most effective samples we have preserved, but other samples we have removed. Okay, so with respect to this, the downsampling sequence is what little bit easier to understand because so many samples we have removed and only few samples are there. That is called downsampling. Whereas upsampling is padding so many zeros here. Okay, so this is how we perform upsampling and downsampling. This is called sampling rate conversion. We generally need it depending upon the device which you are using. Okay, suppose if you consider soft radio, that need only few samples that do not need more and more samples, whereas it comes to image processing you need more and more samples because the accurate information you need to get from the image. Likewise it depends on every device and also every theory which we are where you are using this sampling rate. Okay, that's all for this video. If you like it, share it and subscribe to my channel for more videos. Thank you for watching.